Hello guys, welcome to our project Sentiment Classification for Financial Speculation. And this is Team Quant Team, and the members are John Koenig, Garvit Sardana, and Rahul Sharma. To start with, the aim of our project is to ease the process of financial speculation by using sentiment analysis. Our model just will tell you about the positivity and negativity of the article, and therefore speculate whether the stock may increase or decrease based on the public sentiment. So we're going to compare the articles that are published within the day of the project is used, of the model is used. So due to the scarcity of data sets, which includes sentences that classify sentiments from news reports, we created our own data set. So we opted to focus on comparing LSTM and simple RNN models rather than using sequence to sequence models. And so this enabled us to make our model user friendly, and users just need to copy paste the links that they want to analyze in a .csv file, and the model will make conclusion about the overall sentiment for them without requiring living.
So for our project, we are comparing relative performance on the training and test datasets between our two models, which is LSTM, long short-term memory model, and other one is simple RNN, recurrent neural network model. So both the models are made with the TensorFlow and share the same hyperparameters, but use different activation functions. Uh, for our preliminary tests, uh, for our LSTM, we use sigmoid activation function, and for our simple RNN, we use TANH activation function. Both the models have one hidden layer, as we wanted our test to show model, which model is the ideal base model for binary sentiment classification. And for our data collection and pre-processing, we use Python library called Beautiful Soup 4. We use this library to gather HTML text data from various news websites which had posted recent articles related to tech journalism. We mainly scrapped p tags within the HTML documentations because for the majority of these websites, most of the valuable information was within the p tags.
So for our hyperparameters for the two models, we used exactly the same hyperparameters. We found that these also produce the best results for both models, the most stable results as well. And also made a pretty fair comparison, so we opted to do this. Our training test data split was 80% to 20%. We changed this from our original 70-30 because the limited size of our data set would kind of prevent our model from being able to train very well on a larger data set since we're web scraping it ourselves. Our experimental results indicated that these two models were roughly equal in their training performance on the training data set, although it stands to reason that LSTM is more consistent and robust, and it should probably scale with larger data sets on this specific classification task. And in terms of their output, that's pretty much it. Like, the models both had 71% test data accuracy, but this is only because our test data set is very small. At scale, it should change.